Hi there, welcome back. Welcome to part 2 of this Braun SK2 restoration. And as I promised, when I had some progress, I'd get back to it. And I do. I have done all the recapping. And it doesn't look too dramatic. These are all the caps that I replaced. 6 capacitors, 5 of them are film. Actually, no, 5 capacitors. There's one missing here somewhere. Doesn't matter. I replaced all the caps that needed replacing, and I was actually quite surprised at how bad some of them were. Let me show you. This one is supposed to be 2.5 nanofarads. It's almost 5. This one's supposed to be 5 nanofarads. It's almost 9. Here's another one that's supposed to be 2.5 nanofarads, 3.5 or 3.3. And this guy you might think is 100 nanofarads, so it's out by 4.9%, but it's not. This is supposed to be a 50 nanofarad capacitor, 105. And here we have the electrolytic, the FM ratio detector capacitor, supposed to be 4 microfarads, it's 5.7. ESR of 7.5 ohms. If I change the frequency to 100 kilohertz, which is more than normal, 5.6 ohms. Definitely too high. So all those have been replaced. And just out of curiosity, let's look at the leakage on the capacitance leakage tester. Putting up the voltage. This is a 250 volt capacitor, so I'll put up to 200 volts. On the 10 milliamp range, it's reading just under 1 milliamp. 1 milliamp of leakage. Let me go up to 250. Oh, this is so messed up. That's 1.2 milliamps, 1.3 milliamps of leakage. That is completely useless, that cap. Let's have a look at one of these. What is the voltage on this thing? They're not that high. Again, 1 milliamp range, it's 0.1 milliamps, and that's just on 100 volts. This is running at about 250. I won't even go any further. These things are completely dead. Well, not dead, but they certainly weren't doing the job. And now if you look at the inside, there isn't really that much to see. I mean, 4 capacitors, 5 capacitors. There's 1 down there, 2 down there. This is the electrolytic. I wrapped it in the yellow because the original had a yellow sleeve on it, just to keep it a bit more authentic. There's another one there, there's another one there. And that's all I've done. That is all I've done on here. I did spray contact cleaner into the switches in the pot. Oh, of course. I replaced these two. I actually restuffed that electrolytic capacitor. It was 2x50. I restuffed it with 2x47, 400 volt capacitors, and put this thing back. You can hardly tell. If you look closely, you might be able to see that this on the underside was opened up. But otherwise, you won't be able to tell that this thing's been opened up at all. I've also straightened some of that metal there. There was another bend on the back here, which was straightened. So the result is actually pretty good. I'm going to show you. Let me show you how this thing plays. But before that, let me just show you on the schematic what's been done. Well, here we have the schematic, and as you can see, quite a bit has been checked. All the green has been checked. And the red is the capacitors that I've changed. One there, one there. Those are the 2 electrolytic filter caps that I've restuffed. There's that coupling capacitor there, 2.5 nanofarads. There's another coupling cap here, somewhere there. That one there, that one there, and finally that one there, which is the AGC capacitor. Everything else that's in green is basically continuity that's been checked and resistor values that have been checked to points where I can easily access them. And so far I found nothing wrong with the resistors at all, just with those capacitors. The other capacitors are actually ceramics, and they normally hold out very, very well. I've checked a couple of them. They're perfect. Well, close. Well within spec. So the next stage is to show you the result. By the way, this thing here is the tone pot, which broke apart. I've marked that in red. I'm still trying to figure out how to sort that out. I'm not thinking about replacing it. I'm thinking about fixing it, and I think I may be able to do so. So let me show you how this thing plays now. I've got the mini whip antenna connected to here, and this antenna is actually an FM antenna, a dipole, and what you can do to use for an external AM antenna is you connect one point of the AM antenna to there, and the ground of the AM antenna is connected to the chassis, which is what I've got here. The mini whip is doing the honors here today. So I'm not even sure if this is on, I believe it's on AM. Put the volume up. This will also help with the tuning. Just fit that in there, still cracked. Now mid-afternoon, not normally that good on AM, but look at this. Canary Islands. Madeiran station. This is somewhere in North Africa. Pretty busy for an afternoon. Let's try the FM. With the FM, I take the mini whip and I put it across there and give it long wire. I think this needs a bit of alignment. It's too sensitive, too sharp. It's not perfect, but it's a lot better. And when I first put it on, I did demonstrate this in the first video, but then I did it again later on, and I was finding that the oscillator was kicking in and out on the AM. So sometimes I got something, sometimes I didn't. And when I changed those capacitors, everything came back to life. I think it was actually the AGC cap that was doing that. It was probably damping something too much. But this thing's working and picking up FM. It's got a hell of a lot of volume, a lot of volume. So I'm very happy with this. It's coming along quite nicely. I've also, in the meantime, received some goodies. I must admit that I had actually ordered these prior to the radio arriving. I saw on the listing that the radio was missing some knobs. So I ordered these replacement knobs. One of them has got no pointer, and the other one does. That's typical with these radios. So I've got a set of replacement knobs for when this thing is finished. I got a few extras as well. Good. If only I had a dial glass. Now, as for the dial glass, let me put this off. As for the dial glass, I have not been able to find a replacement, but I have actually been thinking of bending one myself. This thing's got a slight convex shape to it, or concave, depending which way you're looking at it. So, it's not flat, but it's pretty easy to do because this thing is just connected to the back here with basically melted pieces of the surround. They put it there, they start melting bits and stick it on there. So I can actually get this off quite easily. This central bit comes off. There's a clip on there. I'll have to take that off. And then what I think I'll do is I've seen this done before and it was recommended on the comments, is to get a piece of plexiglass, find a curve, something with a curve that sort of matches that curve, which is a very, very gentle curve actually. I have no idea what radius that would be, but it'll be very, very gentle. And then with a combination of heat, patience, and good fortune, I may be able to bend, mold the plexiglass into a curve, let it dry, let it cool down, and then of course just cut it out. I've got to cut that out and then of course cut out the middle one, which will be drilled out, and hopefully that'll work. This red dot is no problem. You just drill a hole there and fill it with paint. Not a hole, just a part of a hole. And I think this will actually be easier to do than I first imagined. The actual surround is in perfect condition, which is something that's a little bit more difficult to replace. I'd have to use this as an excuse to get a 3D printer, but as it is, I don't need one. So that's it so far, and I'm thinking of, I'm actually going to set it up and just do it in the next video. I'll be doing the alignment on here and the cleaning of the chassis, and I'll be showing you that. I'll be aligning the FM and the AM, and I'll do the RF alignment probably. I'm not quite sure how easy it is to do an RF alignment on this. I don't think I did it on the last one because it was in perfect condition, but yeah, I'll be doing that. There's one more thing that I need to do here, and that is, I will show you. I have replaced the filter capacitors, those two, and I have not replaced the selenium diode. Now, the selenium diode is something I do want to replace, and to replace it, I've got to sort of bore out those rivets over there, which happen to be, well, one of them is, where is it? One of them is here. You just get a drill bit and you bore out the rivets. This one I'm going to have to shift this sticker away because I don't want to damage it. Take that out, and then I can do one of various things. I mean, I could very, very simply just put a diode across here, a 1N414007 or something like that, but the voltage there would be too high. Now, I need 175 volts B+. At the moment, what am I getting actually? I don't know. Let me check. Okay, let's switch it on. I do have the dim bulb limiter on there. It's not limiting much. There are 3 light bulbs on, so it's almost without a limit, but it's still there. I want to see what I get. I need 175 volts at that point. I'm measuring at the really at the first filter cap. So the output from the diode, 158. That's on AM. Let me put the voltage up. Bypass the limit completely. 161. 159 on FM. So about 160. 160 volts. Now, this thing is not... It's not quite there. I need 15 or 16 volts more, which I can do by replacing that selenium rectifier. Now the problem here is, if I simply put a diode on there, I'm going to get probably, well, how much will I get? All the components can handle it, so I'm going to just try it. I'm going to put a diode across there. Hang on a second. What I've got here is a 1N4007. And I've just put it across the selenium diode. Now, because the voltage drop across here is much smaller, that selenium diode should be completely bypassed with this one, if it's not leaking backwards. Anyway, I put the dim bulb limiter back on with all the light bulbs in line, so it's not much restriction. And let's just see, without touching this, this is live voltage. What do we get? Obviously it's still not conducting. It's starting now. You can see the tube start pulling current, so that thing comes down. And what does it come down to? We want it down to 175. No, far too high. On FM, 199. Far too high. Okay, I don't want to stress it too much. Now I need to find what resistor I put in line here to give me that the voltage drop that I need. And I'm going to try with 100 ohm. It'll have to be quite a powerful resistor in terms of wattage. But let me try with 100 ohm and see what we get. I've got a 100 ohm resistor. It's a 5 watt. And I've put it in before the diode. So it's actually seeing AC voltage, which is probably a little bit kinder on the resistor, power-wise. So let's try now. It might be too much. We'll see. We want about 175. Here it starts. Looks like it wasn't enough. It needs more than 100 ohms. Will that change much? Not really. So 100 ohms is not enough. Let's see what we need. Put that off. And what else have I got here? Here's 220 ohm. Let's try that one. 220 ohms. Here we go. Now I still do have the limit on there. So 220 ohms, we'll see what that brings us to. 177. Well, that's as close as you're going to get. That is how much I need, 220 ohms. Brilliant. What's it on FM? 174. Perfect. So I need 220 ohms. Now, is that thing getting hot? Let me see if this thing's heating up too much. I don't know how much power this thing's dissipating. I'm reading 36 degrees C. Is it going up or down? It's actually going up a little bit. 38. That's about 39 degrees, probably go up a little bit more. So it does dissipate some heat, not too much, but it does. But the voltage is spot on, 175, 176. That's what I'm going to put in there. Now, why am I putting it in there and not before the... why am I not putting it before the transformer? Well, let's see what our heater voltage is. That'll be interesting. Switch that off. What I want to test now is to see what my heater voltage is. So I've got the multimeter on AC volts. It's across the heater pin on the tube, one of the tubes. And let's put it on. I want 6.3. Now remember, this is without restricting the input voltage. The input voltage is coming straight out. There's a slight restriction. I'm actually going to bypass the dim bulb limiter. Okay, no restriction now. 6.1 volts AC, which is supposed to be 6.3. In other words, my transformer taking my input voltage, which is supposed to be 220. This thing's supposed to be 220, maximum 220. It's set for 220, but I've got 230 coming in. However, the heater voltage is right, coming through without any restriction. It's at 6.2. Should be 6.3. So I don't need to do anything to the input voltage, the input supply voltage, which I could do if I wanted to reduce the entire bulk of this thing. I just need to worry about the actual B+, which we've now determined requires 220 ohms to bring it down to 175 volts. And my heater voltage is spot on. So that means I need to replace that selenium rectifier with a diode and 220 ohm resistor. And I'm trying to figure out how I'm going to do this, because I actually want to try and fit those resistors inside that casing of the diode. It does dissipate heat. It's metal. So if I get, well, let me not talk about this with this thing on. I need to get 220 ohms. I can fit about 5 2-watt resistors in that thing. So if I get like, if I used 5 1K resistors, I'd get 200 ohms. You know, I could use 1.2K resistors. 5 of them would give me, what is it, 240, is it? Anyway, I'll work that out, and I'll probably put 5 or 6 resistors in parallel to do the job of this one, and that means they'll fit inside that casing, and I won't have anything outside showing different to what it looks like now. So I'm going to do that and get rid of this rather high voltage problem. Okay, let me carry on. All right, that's all done. I ripped out the guts of that selenium diode and stuffed it with a diode in series with 4 1K resistors in parallel. So instead of 220, I've got 250, and I don't mind. I think the voltage will be slightly lower than 175. I don't mind that. I prefer that. But I put it in there, and I put some thermal paste just so that the heat dissipation is improved. Hopefully everything is perfectly insulated, and I'm going to switch it on. I've got the dim bulb back to maximum limit. I'm not that brave. And let's see what happens. Remember, maximum limit. This thing's going to be way low, but we'll see what happens, and then I'll start dropping it. Okay, I don't think we have any shorts, so I'm going to bypass the dim bulb limiter, and we're at 180, and it's coming down. That's FM 175. That's interesting. We had about that. Now remember, I had a 220 ohm resistor, 5 watt, and I've put in 4 1K resistors, 2 watts each. So I've got 8 watt dissipation capability, and I've got a 250 ohm equivalent resistor there. And that should do just fine. That's actually perfect. 175, 176 is perfect. I'll put it up to FM. It goes down slightly. So that should do it. And that thing there looks pretty original to me. I prefer it this way. We don't have any unsightly resistors hanging around. So that's the way it's going to be. And I think, folks, that's where I'm going to leave this video off for now. I hope you've enjoyed that. The next one I come back on will be to do some alignment and also to do the cleanup and see what I'm going to do about the chassis. But I'll leave this one for now. I hope you've enjoyed that. And if you have, please click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching. Bye for now, and stay safe.